right, here's page 2 of our review. A man is walking a triangular path, partially represented by the vectors AB, which we said was 6, 4, and CA, negative 8, 2. If his distance is represented in miles, which of these best represents the distance the man travels? And we can't say it's southwest. We don't know what direction it is until we do it. From point B to point C. So the first thing we're going to do as far as our process is concerned, remember we're putting our processes in red. We're going to plot our position vectors and their directions, and then we're going to find the locations of B and C with respect to A. Why am I doing it with respect to A? Because both of those have that in common. And so that's going to be easy to build the framework from. And then we're going to resolve our vectors. Okay? All right, so here's what it looks like. When I said I was going from A to B, it said my position vector was 6, 4. That means I moved to the right 6 and I went up 4. And that's how we got the vector AB. When we had the vector CA, I moved to the left 8 and up 2. So that's how I got that vector. Okay? So that's how, and the whole reason I'm doing that is to get the position of C. So I have two ways that I can do this. I can do it visually based on what I drew, or I can do it mathematically. So we will go through both of those processes. Okay? So if I'm going from B to C, right? Because I want to know the vector value from B to C. I know I'm going down 4, and then I'm going down another 2. So my y value, my change in y, is going to be negative 6. And then if I look at my x value from the end of this 6, which is where B is, right? This is our B, over to C, that's just going to be a value of 2. So my change in x is 2. And so from here, I would do my resulting vector, and that would be 2 squared plus negative 6 squared. And so that would be 4 plus 36, or the square root of 40. Okay? That's one way to do it. The other way to do it, let me see if I can erase some of this without making a mess. The other way to do it is to find your position vectors of B and C, and then use your changes to find them. Okay? So this is option 1. If you're visual spatial, you might like option 1 better. If you are an auditory and you like outlines and you like every detailed step of something, then this option might be good for you. So option 2. The other option, what we could do is look at our position vector for B, our position vector for C, and then label that and find y2 minus y1 will give me my delta y, and x2 minus x1 gives me my delta x, and then I would take those values, square them, and come up with my answer. Okay, so let's look at what my position vector is for B. If I start from A, that's my reference point, I go over 6, up 4. So my position vector is actually 6, 4. And then for C, remember I'm doing this with respect to A. I'm going down 2 and over 8. So that puts my position vector at 8, negative 2. That is opposite of what from C to A was, because visually this is how we're handling it, right? Because C is over to the right. So that truly is my position vector from A. So we're referencing B from A, and we're referencing C from A. And so I would find that difference. And so this becomes, if I'm starting at B and I'm going to C, then this is going to be x1, y1. This is x2, y2. So that would be, y2 would be negative 2 minus 4 equals negative 6. And then x2 is 8 minus 6 equals 2. So I end up with, the same values. My y is 6. -6, and my x is 2. So I have the same values here as I do here. So if I do position vectors and then find the vector, or if I visually kind of map it out, I think visualizing it is a little bit faster. Okay? The other thing is you could make an XY chart, but the challenge with an XY chart, especially on something that's not a right triangle, is a little bit, could be confusing. All right? So that's how we did that. All right, what was the next one that we were adding? What is 0, 0? You guys really punted on that one. 2, 1, and 3, 3 in simplified form. Okay, so we're adding these vectors and their position vectors. So I like to look at all of my x values as my i's, and then all of my y values as my j's. Remember, we do that with our vectors. So I am going to list as i's and j's, line up to add, change sign on anything subtracted. Okay, so that's our process. So let's take a look at this. I'm going to do 0i plus 0j. And then the next one is going to be 2i plus 1j. And then my third one, do you see this negative sign there? I have to distribute that negative sign across both of those. So that's going to be -3i plus -3j. So let's add them all up. And 0 plus 2 minus 3 gives me -1i. And then I shouldn't put the plus here. Let's see what sign we get. 0 plus 1 minus 3 is going to be -2j. So I could say this in rectangular format as -1, -2. Okay, if it wanted, let's see here, in simplified form. Or we could say -i, not plus. I don't know why I keep wanting to do plus. -i minus 2j. So either one of those work. If it asks you for the magnitude of all of them, which is not asking on this part, right? You would go ahead and find the polar coordinate. So square root of -1 squared plus -2 squared. All right. Vectors v and w are defined by, what is v plus w? Okay, so let's go ahead and get those numbers. We said v was 7, 3, and we said w was 4, 5. All right, so we're going to add these vectors. And again, the easiest way to add these vectors, guys, is to convert it into the i's and j's. So we're going to follow the same process that we did right up here. So I'm going to write it as 7i plus 3j, and then 4i plus 5j. And because I'm adding, right, all my signs are good. So 7 plus 4 is 11i plus 8j. So that coordinate is actually 11, 8. Okay? If it has it listed in your i's and j's, obviously you're going to pick that. If it has it in coordinate form, you're going to pick that. If it has it in magnitude form, that would be that square root of x squared plus y squared. So it would be square root of 11 squared plus 8 squared. All right, let's look at number 11. Number 11, we had 4, 5, and 7, 3. I think we did them backwards. If v is equal to 4, 5, and w is equal to 7, 3, which value is closest to the magnitude of u plus w? U? I meant v. I apologize, guys. I must have done this way too late. So again, we're going to add them. 4i plus 5j and 7i plus 3j. So v plus w, I want the magnitude of it. So 4 plus 7 is 11i, and then 5 plus 3 is 8j. So this is where I'm going to go ahead and take the square root of 11 squared plus 8 squared. So let me go ahead and do that on my calculator. So 11 squared plus 8 squared gives me 185. And the square root of that gives me 13.6. So my magnitude is 13.6, whatever those units are. I hate in math that they don't put units on it. It drives me nuts. All right. 12, what is an approximation for the angle measure of theta? The angle between V and U. Okay. So let's go ahead and fill in what we had. We said, again, our little math ad libs, we had 3i, 4j, 2k, negative 6i, 2j, and minus 3k. All right, so it wants to know the measure of the angle. So I put the equation here. So the first step we're going to do is we're going to find u dot v. And I know it's been a while since we've done this, right? So what I'm going to do is I'm going to multiply all of my i's together. Let me pick a different color. So my 3 times negative 6, right? So that's going to be 3 times negative 6 plus, now I'm going to add together my j's. So, oops, let me pick up that different color. 4j and 2j. So it's 4 times 2. And then, let's see here, we'll do orange. Hopefully that shows up. And then I want 2k, and then do you see that negative right there? I'm going to harvest that with my negative 3, or with my 3. So 2 times negative 3. So u dot v is going to be equal to negative 18 plus 8 minus 6. So that value is negative 16. So u dot v is equal to negative 16. Now we need to figure out what the magnitude of u is, and we need to figure out the magnitude of v, and then we're going to multiply. This is a multiplication. This was an image of it. Typically we had just the bars next to each other instead of the dot there, because it makes it feel like it's a dot product. It's not a dot product. Only the top has the dot product. All right, so let's look at u. 3, 4, and 2. That's going to be the square root of my I, so 3 squared, plus my j, 4 squared, plus my k, 2 squared. Yes, it's in 3 dimensions. Yes, we can still get a value. Okay, so we have square root of 9 plus 16 plus 4, and that's going to give me a value of 5.39. And then I'm going to find, is that the value of it? Okay, find the value of, oh, I apologize. That was V, and I gotta change this to U. Here's U. Okay, so U is gonna be the square root of negative 6 squared plus 2 squared plus negative 3 squared. Again, if it's in the if you're squaring it, you can just drop the negatives. So I have 36 plus 4 minus 9. So that is going to give me 4.36. All right, so now I gotta put it all together. So the cosine of theta is going to equal negative 16 over 5.39 times 4.36. And then to get the angle, I'm going to take the inverse cosine of all of that. And I actually, did I put it in the calculator? Yeah. Negative 0.2553 is what I got, right? All of this here is equal to that. And then when you take the inverse cosine, you can go ahead and get the angle, and that angle was 104.8 degrees was my angle. Now remember, it's only tangent that I do that shenanigans with, like adding 180 and 360. I don't do that with cosine or sine because it naturally does what it's supposed to do. It behaves. It does not do that necessarily. And if you get an angle greater than 180, you did something wrong. Because on a dot product, if you're finding the angle of a dot product, it's the smaller angle between the two vectors. Okay? So that is how we found an approximation of the angle measure. So step one, let's get our process down. Step one, we do the cross product. Okay, so we took I times I plus J times J plus K times K. And then the second thing we did was we found the magnitude of U and the magnitude of V by doing that process. And then we put it into the equation. Okay, so there's some pre-work you got to do before you can actually solve this. So this one's going to probably take some time. All right, 13, we're almost done with the second page. So 7, 3, and W is 4, 5. Vectors V and W are defined by 7, 3, and 4, 5. What is V minus W? Okay, so here's what I'm going to do. 7I plus 3J, and I'm going to subtract W. So these values that I have, I'm going to turn the sign on it. So that's going to be negative 4I minus 5J. And I'm going to show you another way to do it. So that would be 3I minus 2J. So it should give you the answer 3, negative 2 would be my difference. The other way you can do it, so that's option 1. The other way you can do it is straight up subtraction. So 7I plus 3J and 4I plus 5J, and you're subtracting. So 7 minus 4 is 3I, 3 minus 5 is negative 2J. Both methods will work. I have a tendency to flip the signs because I make mistakes with signs. So that's a way that I've been able to cope. But this is fine too. Like your traditional subtraction, absolutely fine. Okay? So there is page